What's up, people? Welcome. So sorry for coming late again. Some technical issues, but yes. How are all of my friends, my colleagues, my students doing? All good, people? All awesome. How was your English exam? By the way, once again, I just want to know what was your English exam like, and how's your preparations going for your math exams, by the way? Yeah? All great? Yes? I'm hearing a lot of news from Sana ma'am that your math preparations are going at full swing. That's good to know. Keep it up, people. I know you'll do great. You just need to believe in yourself. Don't panic. Don't, doubt yourself. Don't doubt your abilities. You guys will rock it. Good luck. All right. So anyways, today we're not here to discuss about math, but instead we'll be doing some questions from physics because we have science exams right after that. So we'll do a couple of questions. No, I won't take too much of your time. We'll keep it short and sweet. Few important questions that I feel can come in your term 2 examinations from physics is what we are going to do today. All right. So people, are you all ready? Yes, Krish Malayalam Ariyum. Hi there, what's up? How you doing? Hi Lakshya, what's up? All good. Hi Arunji, what's up? All good. Yeah. I'm a Malayali. How can I not know Malayalam? All right then. Okay then, people. So we'll get started right now without wasting much of your valuable time because I know that you have to prepare for your math exam. So I'll keep it very short and sweet. Okay, before we get started, I have two very awesome announcements to make. The first one is basically the plan we have for you guys for your math examinations by Sana ma'am. So 28th of April, you had the first, session from Sana ma'am. That is the last 1 week strategy preparation for your math. Then 29th, we had the 10, that is today. I believe you had the session, a little before this one. 10 guaranteed question for term 2 examination. On 30th April, that is tomorrow, you will have a class 10 term 2 exam. That is your formula cheat sheet. On 1st of May, you have the last minute tips and tricks for mathematics. On 2nd of May, you have the best sample paper, that is a previous year discussion of previous year question papers. On 3rd of May, 3 things to avoid before your term 2 board examinations. On 3rd of May, once again, you will also have how to study 1 day before exam. 4th of May, you have the complete marathon series where you would be seeing Sana ma'am coming live for about 1.5 hours to 2 hours to do all the topics of math on that day. And then on that very same day, you'll also have live doubt solving. So whatever doubts you got at that time, get that cleared with Sana ma'am because she's going to be here live on the platform to help you clear your doubts. All right, so these are the things that is planned for you guys for your math exam. That is your exam that is coming up in the next couple of days on 4th. I believe it's your exam is on 5th. So yes, so that is when these things are going to happen. So before that, all of these would be happening. And yes, on the same lines, I know exam, means also a lot of stress as well. So to help you cope with the stress also, we have a little session plan for you, which would be coming out today. I'm very excited for that. It'll be coming out today at 8 p.m. Me and Abhishek sir with a new series called as You Hasa, You Fasa. It's basically like you laugh, you lose. It's going to be awesome. I have actually put on the trailer for you guys. If you haven't checked it out yet, let me just check if my volume, the desktop volume is full or not. Okay, so yeah, I'll just play the trailer for you guys just so that you understand what exactly is planned for you people. So let's go. Here we go. Challenge. You can't back out. All right, people. So that was actually what that is going to come out today at 7 p.m. I hope you guys go and watch it. You'll enjoy a lot. It's basically not going to take a lot of time. It's going to help you relax your stress also a little. So that was why we decided to put this out. It's called You Fasa on the channel at 8 p.m. All right. So without wasting much time, people, let's get on to the questions now, shall we? So once again, we have divided the questions into 3 categories. We'll start with the 2 markers, walk into the right 3 markers, and then sprint to the 4 markers, and then get it over with. All right. So people, can I get a oh yeah in the chat box if you guys are all ready? Sir, इसके बाद आपकी हालत, I know. हमारी हालत Modi Sarkar. I want to preparing math, physics will be good break. Oh, that's good. Then let's go. All right. So let's get started without wasting much time now. Okay. So again, I'm going to keep it very short and sweet because you have to prepare for your math. So I'll just keep it very short. We'll run through the questions as soon as possible. So I want you guys to put on the answers as soon as you see the questions so that, it'll save a lot of our time. So the first question is, state Ohm's law. Second question is, how is an ammeter connected in an electric circuit? Now, this is a 2-mark question, which means each of these would carry 1 mark. So let's start with the first question. State Ohm's law. I guess you already know the answer for this. I don't need to explain it, but I'm going to say it anyways. Ohm's law states that in an electric circuit, the current flowing through it is directly proportional to the potential difference across the conductor. In simple words, V is directly proportional to I. Now, in order to remove the proportionality sign, we introduced a constant which is called as R, and hence the formula became V is equal to I into R. But one thing you need to remember is that in order for Ohm's law to be held true, the temperature has to be constant. If the temperature is not constant, then Ohm's law does not hold true. Alright, so that's the only thing you need to mention. That would give you 1 mark. Now for the second part of the question, how is an ammeter connected? Chat box down, put it down. Come on, my boys and girls. You guys are too smart. Come on. How is an ammeter connected in an electric circuit? Yeah. That's all. Kel katam dukan ban. Second part of the answer is what? They're connected in series. Why are they connected in series? Because in series connection, the current remains constant. And in order to measure the current, you could connect them in series with the circuit. That's why an ammeter is there. That's it. As simple as that. Okay, second question. Now, this question was asked in 2019 board examination. 2019 board exam. It's a little hutke. This particular question is not that straightforward. Just to help you see a little better. I'm just gonna change my this thing a little so that you guys can see the question. So here we go, people. Consider the scale of a voltmeter shown in the diagram and answer the following question. So that right there, that diagram is nothing but the diagram of a voltmeter. The first one is, what is the least count by the voltmeter? Second question is, what is the reading by the voltmeter? Very application based question. Third one is, if this voltmeter is connected across a 20 ohm resistor, how much current will be flowing through the resistor? A beautiful question that was asked in 2019 board. So let's start with the first one. How do you connect something called as a least count? Let's go. I know, Andanaji, I know. Who won now? You'll see. So now the way the coil is wound around a solenoid affects its magnetic field. Yes, Anand, I mean, see, it's just that because it is wound like that, there's more current flowing through it. Alright, you can see that there's more current flowing through it. Okay, so let's go, guys. Now tell me, what is the least count in a voltmeter? What is the least count in a voltmeter? This is an absolutely brilliant question. The reason why I'm saying it's an absolutely brilliant question is because you have no idea what least. Majority of you guys do not know what this word least count means. Yes or no? How many of you guys have heard about this word called as least count? Can you put it on the chat box? Do you guys know what least count is at least? Any of you guys who have done Kushagraji? It's sir, it's a front or from back. It started to wound. And that would basically depend, on the image itself. So you just remember this: if current is going in anti-clockwise direction, that is the north pole. If it's going in clockwise direction, that would be the south pole. So the way it is wound would decide the polarity of the solenoid as well. All right. Is it? Okay. I'll tell you how to do this. See, guys, least count is nothing but, imagine you have a scale. The normal meter scale that you have, right? Now, you have 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, goes on like that. All right. Now, between this, you have these smaller lines, right, which shows 0.1, 0.2, 0.3, it goes on like that. There are basically 10 divisions in between. This is what is called as least count. Least count is nothing but the value of one small line. Getting it? The value of that one small line, that is what is called as least count. That is what is the most minimum value that you can get from that scale. What is the most minimum reading that you can get from that scale? That is what is called as least count. Now, when you go to your 11th and 12th, you will learn about something called as a vernier caliper. All right. Over there is actually where you understand and do all this. But just for you to understand, just for you to solve this question alone, I'm telling you what least count basically is. Now, in this question, how do you find out the least count? Now, tell me, guys, what is the maximum value of this voltmeter? Let's start with that. What is the maximum value of the voltmeter? Exactly. 1 unit divided by 1 division. So tell me, guys, what is the maximum value of this voltmeter? 3, because it basically has gone up. You can go a max or maximum. This voltmeter can show a value of 3 volts. Simple. So the formula is least count is equal to the value. Either you can take till 1.5 or you can take till 3 divided by the number of divisions. Now here, people, if you look, between 0 to 1.5 there are 10 divisions, and between 1.5 to 3 there are again 10 more divisions. So what is the total number of divisions? 20. So it's going to be 3 by 20, which will give you a value of 0.15 volt. Got it? I know, Bhushanji, I know. I should be, but I'm a sadist. I'm a sadist. I don't want you guys to study math. I want you to study physics all the time. That's why. No, I just, because we have so much time. No, you have a lot of time. That's why. Chill. It won't take much time. 30 minutes, I'll finish this off. Don't worry. Okay, so people, so that's how you do this. As simple as that. So basically, you need to know either you can take it as 30 by 20, 3 by 20, or you can even take till 1.5, and you can take it as 1.5 divided by 10. Because there are 10 divisions between the two. So once again, you'll get it as 0.15 volt itself. It's totally up to you guys, but this is how you find out the least count. I hope it's clear, people. This is what we do. All right. You can do it. Exactly, Kushakala. That's what I'm going to tell you. So you can either take till here, or you can take all the way till 3 volts. It's totally up to you guys. All right. Now to answer the second part of the question, guys, what is the reading of this voltmeter? Very simple. Till here, it is 1.5. Each division is 0.15. So 0.15 plus 0.15 is nothing but 0.3. 0.3 plus 1.5 is going to be 1.8. So the maximum value, the reading of this voltmeter is going to be 1.5 plus 0.5 plus 0.15, because each division is 0.15, which would be equal to 1.5 plus 0.3, which will give you a value of 1.8 volt. So the answer is going to be 1.8 volts. Got it? Okay, next one, guys. If this voltmeter is connected across a resistor of 20 ohms, how much current will be flowing through the resistor? Yet another simple, easy peasy question. So let's go ahead and do this one, guys. Come on, very quickly, put it on the chat box. The resistor is given as 20 ohms. The value of the resistance is 1.5. It's very easy. So for the third part of the question, all you have to do is use your Ohm's law. V is equal to I into R. You need to find out I. So I is equal to V by R, which is equal to what? 1.8 divided by 20, I believe it's 20 ohms, right? 20, which will give you a value of 0.09 amperes. That's all. Got it? Got it, boys and girls? That's all. Easy. But yeah, I mean, this least count question though, a lot of you guys might have never seen this before, or you'd have probably seen this and you did not know how to approach this, but this is how you do it. All right, it's basically nothing but the value, the total value, the max value, or whatever value you want to choose, divided by the number of divisions between 0 to that value. That will give you the least count. As simple as that. All right, that's it, guys. All right, moving on to the next question. Again, I'm going to rush up a little because I want you guys to prepare for math as well. Moving on to the next question. It's from 2017 board exam question. Here is a question. Draw a sketch of the pattern of the magnetic field due to a current carrying coil, circular coil, and a current carrying solenoid. Very simple question. I think you already know this. I'm not going to do the diagram, all right, because I'm very good at diagrams, so I'm just going to show it to you directly. Here's the first one. It's going to look like this. You'll have concentric circles for a circular loop. You'll have concentric circles. So basically all you have to do is draw these concentric circles. It gets bigger and bigger as you go towards the middle. And you can see that over here, it's going to get straighter and straighter. And at the center, you would basically have a straight line. This is what the magnetic field lines look like for a circular coil. On the other hand, if we talk about a solenoid, the magnetic field lines would look like this, very similar to that of a bar magnet. So whatever you remember in your past grades, whenever you've learnt about the magnetic field of a bar magnet, for a solenoid, it's exactly the same thing. So you can just put it down over there. As simple as that. All right. Moving on, guys. Moving on. Let's go on to the next question. And the fourth question for today, again, let's do it quickly so that you'll have enough time for your math. Again and again, I'm going to say this. Fourth question is, name and state the rules used to determine the direction of magnetic field produced around a straight current carrying conductor. What is the name of that rule, which basically helps you to find out the direction of the magnetic field around a straight current carrying conductor, and also state that rule, which would again give you yet another mark. All right, let's go people, let's go. Sir, in magnetic effects of electric current, we will have numericals. No, there, absolutely not. The only thing you need to mention is this one, at F is equal to BIL. Maybe you'll have to show the relationship, that is force, Lorentz force is directly proportional to the magnetic field, directly proportional to the current, directly proportional to the length, but you will not have any numericals based on it. Absolutely, Kati and G. Niveda, absolutely. It's nothing but the right and thumb rule. You can just mention it as Maxwell's right and thumb rule, or as simple as right hand thumb rule. So right hand thumb rule is the one that is used over here in order to find out the direction of magnetic field around a straight current carrying conductor. If you want to state the rule, it basically goes like this. If you were to hold a straight current carrying conductor in your right hand, such a way that the thumb shows the direction of current and all the enveloping finger shows the direction of the magnetic field. As simple as that. Simple. All right. Moving on, guys. Moving on to the next question now. So we are done with the 2 markers right now. As of now, we are completely done with the 2 markers. Now let's walk right into the 3-mark questions, which again is going to be a little bit more descriptive in nature, but not going to be really that difficult. All right. So people, are you guys ready for this one? Let's go. Yeah, sure, Dash. Absolutely. Why not? Let me just adjust the camera. I don't know why the slides look like this. I don't know why that is happening. All this will happen only to me. Nobody else will face all these problems. Exactly, with AJ. Exactly. All right. So I'm going to go ahead with the next set of questions, people. All of these would belong to the 3 markers. So here's the first one. What is meant by a solenoid, and how does a current carrying solenoid behave? Give its main use. 3 parts, each carrying 1 mark. All in all, an easy 3 marker. Okay, what is meant by a solenoid? Let's go. Kushagra, sorry, what? Yeah, I know. I only gave the photo, but yeah, it was actually, I wasn't expecting that sort of response from it. Honestly, I thought you guys will, confuse me with someone else, but no. Like when I saw the chat, I was like, everyone knew it was me. How? I look completely different from what I was over there. I don't look anything alike like how it was. I mean, people who walk into my house, like, so the thing is this photo, no, is actually a framed photo that my mom has kept on there's a what to say, it's like a small showcase kind of thing, so she's put it over there. Like, who walks in, they always ask, like, who is this? Because, they don't recognize me at all. But how did you guys find out? I really don't understand. Anyways, okay. So what is meant by solenoid? How does a current carrying solenoid behave? A solenoid is nothing but an insulated copper wire which is wound to look like a cylinder. Or you can say that a solenoid is an insulated copper wire where n number of turns or n number of insulated copper wires are put together to form a cylinder. Now, whatever way you explain, that is up to you, but at the end of the day, you would have to go with either of these 2 ways of explaining things. Now, how does a current carrying solenoid behave? It basically behaves like a magnet, a temporary magnet or an electromagnet, where as long as the current is flowing through it, it behaves like a magnet, but the minute the current stops flowing through it, it stops behaving like a magnet. Now, what is the main use of this? The main use of a solenoid is basically to create temporary magnets or permanent magnets, or to be used as an electromagnet in certain devices. That's it. As simple as that. All right. So that is the answer, guys. Again, you can download all these notes later on, so don't worry about that. So make sure that you keep in your mind these small points so you don't forget it on the day of your exams. All right. Here's another one, people. CBSE 2018 board exam. Once again, it's a 3-marker, a very simple 3-marker. In fact, we have done very similar kind of question in the previous session also. The last time I came up with this one. So the question is, show how would you join 3 resistors, each of resistance 9 ohms, so that the equivalent resistance of the combination is 13.5 ohms and 6 ohms. So each of these would carry 1.5 marks, which gives you a total of 3 marks. So go ahead, people, put it down in the chat box. Let's go. I know. I'm always cute, no? That's a problem. Kya kare? हम पैदाइश cutie है. क्या करें? Exactly, Kushakra. Fantastic. Yeah, exactly. That's what I'm trying to tell you. We have done this similar type. That's why I mentioned this. We've done the similar type of question in the previous session also, so it's very simple for you guys. So question is not visible properly because of your video. Oh, sorry. Yes, papa. Eating sugar, no, papa. Okay, there's a honeybee in my place now. All right. Chill out. Okay, let's go. Exactly. Now, for the first one, if you want an equivalent resistance of 13.5 ohms, I would say connect two in series because the resistance is comparatively a little higher, and maybe one in. Let's try out both the combinations. Let's try this one first. 2 in series, 1 in parallel, or you could try 2 parallel in 1 series. I think 2 parallel 1 series would actually give you 13.5 ohms. Yeah, let's go with that first. All right, just to avoid confusion, let's go with that first. So let's say I connect 2 of them in parallel. Again, it's trial and error, guys. It's just trial and error. 2 in parallel and 1 in series. Let's try to calculate the equivalent resistance over here. For this, the equivalent resistance is going to be what? It's going to be 1 by 9 plus 1 by 9. That is, R equivalent is equal to 2 by 9, which is equal to 9 by 2, which is equal to 4.5, and this is connected in series, so the total resistance is going to be 4.5 plus 9, which would give you 13.5 ohms. Absolutely wonderful. All right, so this is the answer for the first part of the question. Now to move on to the second part of the question, again, there's only one other combination that you can do, because connecting them in series and parallel alone will not give you the resistance of 6 ohms. So the only option that I have left is basically to connect 2 of them in series and then 1 in parallel. As simple as that. So you have 9 plus 9, which is 18. So it's going to be 1 by 18 plus 1 by 9 into 2. That's going to be 1 plus 2 divided by 18, which is going to be equal to 3 by 18. So the final answer is going to be 18 by 3. 3 6 are 18. So it's going to be 6 ohms. As simple as that. All right. So this is the answer for this question. So again, it's all about trial and error. Now, if you feel like you want to try out the series one, all connected in series and all connected in parallel, that is also up to you guys. But I would suggest you not to waste too much time on this, because it's only a 3-mark question, and in majority of the cases, these are the kind of combinations that you would be getting. So go with that first. All right. And if that doesn't work, then try the other combinations. All right, let's go on to the 7th question, people. 2013 board exam. The question goes like this. Describe an activity to show with the help of compass that magnetic field is strongest near the poles of a bar magnet. B is, mention the direction of magnetic field lines inside a bar magnet and outside a bar magnet. Like bacha question. Where's AKR sir? AKR sir is chilling in Coimbatore right now. AKR sir is chilling in Coimbatore. AKR sir is gone on a drive and all. With Mrs. AKR. Both of them have gone for a drive. They are in Coimbatore right now, chilling like a villain in this beautiful weather. He's chilling like a villain. All right. Okay, let's go. We will tell me the answer for this one. Describe an activity with the help of compass. I think it's a very simple question, people. I think you can all do this. So all you have to do is use a compass near day. No, wait. Thing is that, guys, I'm actually very scared of honeybees. All right. So I'll tell you why. So when I think I was in 5th standard. Yeah, 5th standard. So I was sitting on the terrace. I was sitting in the, we had a, I was in tuition, not tuition, I went to meet my friend actually. We were doing combined studies. So we were doing combined studies, we were sitting on the terrace and we were doing combined studies. And this honeybee came and bitten me right above my right eyebrow. And ever since then, no, the minute I see a honeybee, it's caused a trauma inside of me. Like, getting it? Like, I'm actually scared of honeybees. So the minute I see a honeybee inside the room, no, I make it a point that I murder it on that very day. Yes, I'm a honeybee murderer, but I put my life above the honeybees. Sorry. Okay. Anyways, let's go. Mimicking. When did I mimicry? Why would I mimicry AKR and all? He's mimicking me. Okay. Let's go. Stomach. All right. So yeah, all you have to do is very simple, guys. All you have to do is take all you have to do is take a current carrying conductor, take a magnet and bring it near the poles. If you take a solenoid and bring it near the poles, you'll see that there'll be a greater deflection of the needle inside the compass when it is brought near the poles than when it is in the middle, which basically indicates that the magnetic field over there is much more stronger than in the middle. So it's as simple as that. All you have to do is take a compass, bring it near the solenoid, near the poles. As soon as you bring it near the poles, you'll see a greater deflection, and the minute you see a greater deflection, you know for a fact that it basically has a stronger magnetic field right there and then. Now, what is the magnetic field direction inside the bar magnet? Very simple question, guys. Inside the bar magnet, what does the magnetic field look like? So, Janta Mrs. AKR ka naam jana chahti hai. What is that? There is this. It has got. I learned a new phrase in in Hindi. It's called Ram Naam Japna Sabka Paper Apna. Alright. Like, I don't know. I just wanted to say it because I want to deflect you guys from that topic now. New phrase. Ram Naam Japna Sabka Paper Apna. Alright. Okay. South north. Absolutely, guys. Absolutely. So inside the bar magnet, the magnetic field lines are going from south to north, and outside the magnetic field lines go from north to south. Fantastic, guys. Fantastic. Absolutely awesome. Alright, absolutely. Alright, moving on to the next question, people. Let's ignore the chat. Let's go to the next question. Here's another question. I believe this is the 8th question, not the 7th one. List the factors on which the resistance of a conductor depends on the shape of the wire. Like, how does the resistance of a wire depend on the shape of the conductor? Second one is, why are metals good conductor of electricity whereas glass is a bad conductor of electricity? And lastly, why are alloys commonly used in electrical heating devices? Alright, let's start with the first one now. When you talk about the list, when you talk about the shape of the wire, what are the factors that the shape of the wire affecting, or how does the shape of the wire affect the resistance of a wire? Let's go guys, let's go. Absolutely. Area of cross section is 1. So resistance is inversely proportional to area of cross section. The greater, or in other words, if the wire is a little more thicker, then the resistance of that wire is going to be comparatively a little lesser. Alright, any other factor that you can think of, people? Area of cross section is 1, which is basically going to decrease. The thicker the wire, the lesser the resistance. Any other reason that you can think of? Anything else? Exactly. The length, guys, absolutely. The length of the wire is also another factor. Length and resistance is directly proportional to each other. The greater the length, the greater the resistance. Now, just to be on the safer side, you can also mention the temperature and resistivity as well. So you can mention that resistivity is also a factor that resistance depends on, and resistance also depends on the temperature. The greater the temperature, the higher the resistance. So all of these are the factors on which resistance basically depends on. Fantastic. All right. Now to answer the second part of the question, guys. Why are metals generally good conductors compared to non-metals like glass? Let's go. Let's go, people. Come on. Quickly. Let's go. Exactly, because metals generally have higher free electrons or valence electrons, and that is why they're better conductors. They have a lot of free electrons, lots of free electrons they have compared to electrons. This is why metals are better conductors than non-metals like glass. All right, next one. Why are alloys commonly used in heat? Like for example, guys, imagine that you have a room heater or a water heater. Why is a pure metal, like for example, aluminum or iron not used? And instead, why do we use alloys like nichrome and all that? What is the reason for that? I know, Vandana ji. Physics to sab mein hai. Ram naam japna, physics sabka. Physics apna apna. Higher resistivity, absolutely fantastic, exactly, because alloys, because the mixture of both the mixture of several different elements, it would have higher resistivity in comparison to pure metal, and that is what you want. You want higher resistivity, so you have higher resistance, and higher the resistance, the more the heat produced in that circuit. That's absolutely fantastic, guys. Moving on to the next question, and let's go on to the next question quickly. 8th question. This is a fantastic one as well. The following diagram shows two parallel straight conductors carrying same current. Copy the diagram and draw the pattern of magnetic field lines around them, showing their direction. What is the magnitude of magnetic field at point X, which is equidistant from the conductors, and give justification for your answer. It's a beautiful question. Let's try to figure out the answer for this one. All right, let's try to figure out the answer for this one. Okay, for the first one, I think the first part is quite straightforward. If you need to find out the direction of magnetic field, all you have to do is what? Tell me, people in the chat box. Tell me, people in the chat box. Exactly. All right, let's talk about this one first. What will be the direction? How would you find out the direction of magnetic field if you have two straight current carrying conductors, wherein both of them the current is flowing in the downward direction? Exactly. All you have to use Maxwell's right and thumb rule. So according to Maxwell's right and thumb rule, when your current is flowing in this downward direction and you hold the conductor, you see that the magnetic field around it would look something like this. So it would basically have this sort of direction where you see that it's going in, you can see it's going in clockwise direction. That is the direction of the magnetic field. Now, what would happen to point X? That is the question. See, the thing is, guys, this point X is actually equidistant from both. The equidistance means if this is 5 centimeter, this is going to be 5 centimeter itself. They're going to be of the same distance. So if that is the case, and since if you look at this point A, if you look at point X, on the first one at point X, the current is going in downward direction. Same point X, but because of wire number 2, the magnetic field is going in the upward direction. So what would happen is that they would cancel each other out, and at point X, the magnetic or the magnitude of magnetic field would actually be equal to 0. Magnitude of magnetic field at that point would actually become 0. All right, it's going to be clockwise. Are you able to understand this? It's equidistant. So both, one side it's going downwards, the other side is going upwards. You can see that point X, you can see one is going down, the other is going up. So it's going to cancel each other out, and because it's same amount of current is flowing through it. See, if the intensity of current was different, then it would have been a different case. But here we are assuming that the intensity of current is also the same. If that is the case, the magnetic field will also be the same. So at point X, the magnetic field would actually be 0. All right, I hope you got it, people. So that is the answer for this. Exactly. All right, exactly. Magnitude is equal, but opposite in direction. Fantastic. All right. So people, with that said, let's go on to the last, question for today, which is basically a 4-marker. And this 4-marker question is by far the last one. That's the most important one, if you ask me. The question is actually very straightforward. So let's go ahead and do this. The question is, for the combination of resistors shown in the following figure, find the equivalent resistance between M and N. Okay, where's the figure, by the way? This is the figure. You have to find, where's this figure? So yeah, M and N are the 2 points given. You have to find out what is the equivalent resistance at between M and N. What is Jules Law of Heating, and why we need a 5 ampere fuse for an electric iron which consumes 1 kilowatt power at 220 volts, and why is it impractical to connect an electric bulb and an electric heater in series? Another super awesome question. It's a 4-marker, so each of these would carry 1 mark. There are 4 parts to it, A, B, C, D, each would carry 1 mark. So let's start with the first one, people. What is the equivalent resistance between M and N? It's going to be very simple. I believe you can easily do this. So first thing first, solve for this. What will you get it as? So 1 by R34 is equal to 1 by R3 by 1 by R4, which is equal to, you can just cross multiply if you want to, or keep it as it is. It's totally up to you guys. I'm going to cross multiply for the sake of it. So you'll get it as R3 plus R4 divided by R3 R4. This, again, you have to reciprocate this. So R34 is equal to R3 R4 divided by R3 plus R4. This, then once you solve for that, they're all connected in series. So solve for that. So R equivalent will be equal to R1 plus R2 plus R3 R4 divided by R3 plus R4. As simple as that. Got it? So that will be the answer for this question. Very simple, very straightforward, absolutely fabulous. Moving on to the next one. State Jules Law of Heating. Come on, my share or share Neo. Put it on in the chat box. Jules Law of Heating. Exactly. Fantastic. Now, what is Jules Law of Heating? Put it out in the chat box, people, quickly, so that let us move on to the next one. All right. Oh yeah, let's go, people. What is Jules Law of Heating? Simple da. Bacha question again. Let's go. Absolutely. It's nothing but, people. According to Jules Law of Heating, heat energy produced in a circuit is directly proportional to the square of the current, directly proportional to the resistance, and directly proportional to the time for which current is flowing through the circuit. So this is the formula. Please explain it. Heat is directly proportional to the square of the current. Heat is directly proportional to the resistance. Heat is directly proportional to the time for which the current is flowing through the conductor as well. So that would be the end of that question as well. Moving on to the third question. Why do we need a 5 ampere fuse for an electric iron which consumes 1 kilowatt of power at 220 volts? A brilliant question. Honestly, it's a brilliant question. So let's write on the given data. Power is given as 1 kilowatt, which is nothing but 1000 watts, right? And the potential difference is given as 220 volts. Now the question is, find out the current in this. So how do you find out the current? So current is equal to what? P by V, because we know that P is equal to V into I. Simple. Substitute the values over here. So 1000 divided by 220, 0 gets cancelled. 2, 11, 2, 5, 10, 0. So it's going to be what? It is going to be equal to 4 point something. How much will you get? The current value you'll get it as 4.44, 4.5 or 4.6, something like that, 4.54 or something like that, close to that. I don't know, I'm not really sure about the value though. It will be around 4.54. 4.54 is the right answer. My math has become excellent now. So 4.54 is the answer for this question. So that would be the end of that question as well. Super easy numerical, but a very interesting one. All right, last one. Why is it impractical for you to connect an electric bulb and an electric heater in series? Why do we not connect them in series? जशवंत जी, हम तो मैथ नहीं पढ़ाते, सना मैम पढ़ाते हैं मैथ. हम मैथ पढ़ाएंगे तो आपको 0 नंबर अंडा आएगा. अंडा फोड़कर आप ऑमलेट बना सकते हो इसके बाद, आफ्टर एग्जाम्स आर डन. ऑलराइट, do not mess with me. All right, okay. Let's go to the last question. Quickly put it on the chat box, guys. What would happen? Why is it impractical for us to connect? Electric bulb and electric heater one after the other? The answer is quite simple. Current is constant, but then if current is constant, then okay. See, the major reason why we would not connect a bulb and an electric heater is because, see, any device for that matter, any device needs a minimum value of current or minimum potential difference for it to work. Now, if you connect them in series, the problem is, guys, in series connection, the voltage does not remain constant. The voltage changes. And according to Ohm's law, we know that V is proportional to I. So the voltage across the bulb will be higher because that is the first device. but across the heater would actually be less. The minute the voltage becomes less, the current will also reduce. Now, in an electric heater, you want heat energy to be produced. According to Jules Law of Heating, H is directly proportional to I squared. So, if current is less, heat produced will also be less. That's why. Got it? Because the potential difference will not be the same across 2 points in series connection, and because of that, the current flowing through it would also reduce. That's the answer. All right. So that's it, people. That's all from my side. I am not going to keep you guys long. That's all. That is it from my side. Now, for all the students who are already here, who I believe you already know about Drona and the pro classes. So it's going to be it's not going to be AI live anymore. It's going to be called as pro, pro classes. So all of the details of the pro classes is right in the description. Now I'm going to not take too much of your time because I know that you guys need to go and prepare. So I'm just going to stop it from here, guys. From my side, all done for today. So yes, if you have any doubts, please let me know, because again, I want you guys to go and give your best in your math exam as well. And I want you guys to, forward ke aana. That's all I can say. Forward ke aana. All right. So have a blast and make it worth it. All right. You've put in a lot of effort for the past, God knows how many months now. So make sure that you guys, giving your best over there. All right. And have, don't be nervous. That's all I would say. Don't be nervous. Stay calm. Everything's going to work out. Just stay calm and give your very best. That's all. All right. What is the challenge? You will know in another 20 minutes, in another 14 minutes, you'll know. All right. So do not forget to check out the video. It's going to be awesome. It's going to be a lot of fun. I had a lot of fun making this video though. For the first time ever, we tried something out, something different rather than, all this regular sessions and all that. We had a lot of fun making it. Tons of fun making it. Honestly, like the BTS of this video is going to be even more amazing. The BTS of this video, it'll be even more amazing. Do check out the video. It'll be out in another 13 minutes. So I'll catch you guys then. Take care, people. See you all in the next one. My next session would be announced soon, because right now we're focusing more on math. Once math exam is done, then we'll start with the marathon of science as well. All right. Oh yeah. It's brilliant. It's gonna be awesome. All right. So all right, people. I'll catch you guys later. Take care of yourselves. Violence. I don't like it, but violence likes me. So I'll catch you guys later. Take care. Peace out. Stay safe. And I don't know, I'm blurting out random phrases today. So yes, once again, Ram Naam Japna, Sabka Paper Apna. Take care. See you all. Have a great evening, great day, and check out the video. Don't forget. See you soon. Peace out. Bye guys. And share the video also. Share that video with as many people as possible. To all of your friends. All right. Give me your word that you'll share with all of your friends, because that video is really awesome. I want all of you guys to have fun, relax yourself a little, and have a blast watching it. All right. It's going to be a good stress relief, a stress buster before your actual finals. All right. So go share the video and ji le apni zindagi. Take care. Bye bye. See you all. Peace.